If cosine theta equals 5/13 and theta is in quadrant 4, we want to determine each trig function value. So to find these trig function values, we're going to sketch the reference triangle for angle theta. And since theta is in quadrant 4, or this quadrant here, let's go ahead and assume that this is the terminal side of angle theta, which means the reference angle would be the angle between the x-axis and this terminal side, or this angle here. So we'll call this theta sub r, and the reference triangle would be formed by sketching a segment from the terminal side that's perpendicular to the x-axis, or a segment like this. So now we have a reference angle and we have the reference triangle, which I'll outline in black. So if cosine theta is equal to 5/13, that means the ratio of the adjacent side to the hypotenuse must be 5/13. So we can label this leg of the reference triangle 5 and the hypotenuse 13. An important thing to remember about reference triangles is that the legs can be positive or negative, but the hypotenuse is always positive. So now when we go to find the length of this leg here, which we'll label y, since we're in the fourth quadrant where x is positive and y is negative, we'll label this leg as a negative. Now we should recognize this right triangle as a 5, 12, 13 right triangle, but just in case we don't, we can find y using the Pythagorean theorem. We would have y squared plus 5 squared must equal 13 squared. So we'd have y squared plus 25 equals 169. Subtract 25 on both sides, we have y squared equals 144. And now square root both sides of the equation. Remember, y can be both positive or negative, so we have y equals plus or minus 12. And again, because we're in the fourth quadrant, where the y-coordinate is negative, we're going to label this leg negative 12. So for this point on the coordinate plane, the x-coordinate would be positive 5, and the y-coordinate would be negative 12. But now that we have our reference triangle, we can easily find these 5 trig function values. Sine theta is equal to the ratio of the opposite side to the hypotenuse, or negative 12 divided by 13, or negative 12/13. There's two ways to find secant theta. Since secant is equal to the reciprocal of cosine, and we're told cosine theta equals 5/13, then secant theta is equal to the reciprocal, or 13/5. Using the reference triangle, we would use the ratio of the hypotenuse to the adjacent side, or 13/5, which we already have. And there's two ways to find cosecant theta as well, since cosecant is equal to the reciprocal of sine, and we know sine theta equals negative 12/13, then cosecant theta is equal to negative 13/12. Or using a reference triangle, we'd have the ratio of the hypotenuse to the opposite side, again, negative 12/13. Tangent theta is equal to the ratio of the opposite side to the adjacent side, which would be negative 12 divided by 5, or negative 12/5. And then again, for cotangent theta, since cotangent is equal to the reciprocal of tangent, if tangent theta is equal to negative 12/5, then cotangent theta is equal to negative 5/12. Or using the reference triangle, we'd have the ratio of the adjacent side to the opposite side. 5 divided by negative 12 is negative 5/12. I hope you found this explanation helpful.